The next challenge I'd like to discuss is traffic. Americans spend 3.7 billion hours in traffic each year. And this costs a fair bit of money. For instance, in Chicago area, you can spend close to $1,600 a year just because you're stuck in traffic. Because it wasted time, time is money, and extra fuel. Same in California, DC. St. Louis a little less. It's still almost more than $800 sometimes. So can we come up with better ways of dealing with traffic? Army ants are great inspiration. They are these little ants. And you see they go back and forth to their nest. The nest actually moves through over the forest floor every couple of days, but they can be up to 200,000 workers in these parties that go out, these raiding parties that go out every day looking for food, for prey. However, they're nearly blind, but they do not bump into each other. They don't get into fights. The trails are maybe 20 meters wide, but can be up to 100 meters long, so they can go fairly far out. And they collect 30,000 prey items a day, and then the colony shifts to the next area where there may be more prey. They employ very simple mechanisms to organize this traffic flow and to minimize congestion, that they don't get stuck in a certain place. And they do this by forming separate traffic lanes within the foraging freeways. There's actually lanes here that they are, and rules that they are following. And this is work by a researcher from Princeton University. And the way they model this is by just following certain ants. And here is an army ant with the incoming ants carrying food. So these are the ants that are going to the nest. This is the ant that has food, and now it's carrying the food with it. It's actually leaving a trail, a pheromone trail, to give information about where this food was found, what the quality was of that food. And then there are these outgoing ants. They go back to where that food may be, and they use very simple rules. Like if they come too close to the trail or to the incoming ant, they will just turn away from the trail, and the same here. And this is just by having these very simple rules. This is how they do not bump into each other, and how they keep the lane free for ants that are bringing stuff back have an unimpeded travel. So maybe the application could be for traffic control. And I was not able to actually get this video on slatetv.com. There's a great video of ants inspired traffic control, and I suggest you take a look at that. There's also this vehicle platooning and automatic highways that has been used, where you could have these very simple rules that cars can follow each other at a certain distance, go at a certain speed, and then and stay away from the next car that they may meet up with, and stay at a certain distance. And that is maybe a way you can increase traffic. Another inspiration is insect swarms. There's these, you can have huge swarms of insects, yet they don't bump into each other and crash to the ground. They are able to get to where they're going. For instance, this is a desert locust and Mormon crickets. They swarm. This one is, of course, not swarming. It's eating something, and I'll tell you later what it is. And then honeybees, when a queen wants to start up a new colony, has to start up a new colony, pretty much the whole colony lifts up and moves to another place. And it seems kind of random, but it's not. They all go a certain direction, and they do not bump into each other. So there actually have been applications for this. The swarming robots, these giving them certain rules that they should follow. You cannot be too close to other robots. You all have to go in a certain direction. This is your leader. This is the robot that's the leader.